Hi, welcome to the periodic table with Celeste. First, we'll start with the basics. First, we have the metals, which are shown in light blue on the left side of the periodic table, except for hydrogen, which is a nonmetal on the right side of the periodic table. These two groups are divided by the metalloids, which are divided on a nice diagonal line, zigzag line. Next, we divide our periodic table into even smaller groups, 10 smaller groups to be exact, starting with the alkali metals in here on red, and the alkali earth metals in group 2, except for hydrogen, which is another nonmetal. Then we have purple, which is the transition metals, and below them the lanthanides and the S-tenides, the two bottom rows of the periodic table. Again, we have the metalloids, which divide the metals and the nonmetals of our periodic table. This is shown in green. To the left of the metalloids are the other metals, and to their right is the other nonmetals. Group 17 is comprised of the halogens, and Group 18 wraps up our grouping with the noble gases, which all have full valences with 8 electrons. Now, dividing these elements into groups is okay. That helps us understand their meanings and their purposes, but dividing atoms and elements themselves normally result in catastrophic ideas such as the atomic and hydrogen bombs. Now, what do all these numbers and letters mean in the element square? First, we have the atomic number. This is a chronological number that the farther you go in the periodic table, the higher the number is. 1 through about 117 or so. Next, we have the symbol. The symbol is normally an abbreviation of the name of the element that it's referring to, but not always. Sometimes, like in the case of potassium, whose symbol is K, it has really nothing to do with the actual element. Next is the element name. I chose americium, named after our beautiful country. Americium also has an atomic weight of 243. The atomic weight gets higher the further you down you get in the periodic table, and the atomic number is in accordance to the atomic weight. The atomic weight sometimes varies due to ions, but this atomic weight on the periodic table is an average of all those ions. Now, americium is also used in smoke detectors, just for your information, if you had never heard of this element before. Now on to periodic trends, what's in and what's not. For key reference in this slide, I'll be using this arrow down here. The smaller and decreasing side of the trends will be shown by the blunt end of the arrow, whereas the increasing or bigger side of the trends will be shown by the pointy side of the arrow. In ionic radius and atomic radius, as the grouping goes down, the periodic table trend increases, but whereas it goes farther to the right, it decreases. Wherever in electronic negativity and ionization energy, as the periodic table goes farther down, the trend decreases, and to the farther right you go, the trend increases. Remember this, it's vitally important. Another thing you'll be using for the rest of the year in chemistry is charges. Charges are pretty easy to remember. They start with group 1 being a charge of positive 1, and move on to charge 2, or positive 2, in group 2. Then we skip the entirety of the transition metals. Transition metals are aptly named because their charges normally depend on the metal and the problem you're working on. They can be 1, 2, 3, doesn't matter. Now we move on to group 13, which has a charge of 3. And skipping group 14 because of its charge of 0, we go on to group 15, which starts our negative charges with negative 3, then negative 2, and finally group 17 with a charge of negative 1. Sadly, folks, that is the end, and this video and I are gone. I slapped my knee on that one.